Hi everyone, I'm Joey. We just finished this set of stairs. I've got to get it off site real quick, so I'll make this real short. Watch the video. Okay, so we started out by making this giant full-size mold. We CNC'd the curved top and bottom of the mold, and then just threw a bunch of studs around the curve. Also, I would like to just say that this video is not entirely linear. I pieced together, I think, as best as I could all the different parts, but there's a bit of jumping backwards and forwards depending on what was able to be filmed. It was pretty cool to have the chance to have my dad helping me out on this job. He has done one other spiral staircase before, so used some of his experience, and we just kind of ended up making most of it up as we went along. Okay, it's a bit hard to see, but we have our first form clamped in place. This is for the taller set of stairs. And what we have to do over here, it's very difficult to see again, we're making a template here for a big piece of steel which is going to hold the stairs up. Of course that's going to be up here, but I need to get those steels manufactured while we're making the rest of the steps, so that's what's happening now. That's 10 sheets of 6mm birch ripped. I've got another 10 to go. I'm going to stop and have a cup of tea. But yeah, that's what we're going to make the stringers out of. So, fun times. I forgot to mention on that last clip, a few parts of the stairs have been professionally engineered by a structural engineer who specialises in these curved type arrangements. So I mentioned I had to get a big steel plate made. And there's one at the top of each set of stairs, and that stops stairs wanting to twist. And so that's just to satisfy building regulations and council regulations and things like that. And so there is some special kind of calculations involved in the handrail as well, but that's a bit down the track at this point. Okay, the next major issue we have is how we're actually going to glue up all these veneers. So I've done a bit of research about the quickest way to glue veneers up, and it really all comes down to having some specialized rolling glue machines, which would be nice, but don't have one. So this is a concept that I saw back in the day when I was like 17, 18, when I was making skateboards. So at the time I heard about it, it was called a glue bath. Essentially you make a little shallow box and either fill this with glue and dip the veneers into it and then kind of squeegee the glue off, or put the veneer in here, pour some glue on, and then kind of just trowel the glue along the surface, and then the excess glue is caught in the tray and you can scoop it back out. So I think we're going to try one of those versions just to try and speed up the gluing process, because we have each stringer is 10 veneers thick, and I think we need 20 veneers for each stringer, so it's quite a lot of gluing to be done. Okay, let's do something. This gluing process worked pretty good. This was the first one we did, and so it took us about an hour, I think, to get this one sorted out, which is right on the limit of probably what we should be doing. But we got faster and faster at it as we got used to working with the glue and how to actually get the veneers up into the mold. where there was a butt join in the veneers, we stapled them together to stop them spreading apart as they were clamped into the curve. This worked mildly successfully. Alright, so we got two stringers glued up. So because there's two sets of stairs, one is slightly taller than the other, but we're going to use the same mold. So before we shift our mold up to do the higher set, we're going to glue up the handrails in the same position down here, and then we'll do the same at the top. So we've taken a whole bunch of solid maple, ripped them down to 10 mil. And we're going to bend these around the same form, and this will create the handrail blank. So that's the mission for today, at least. The outside handrail and stringer, for that matter, are about 5.4 meters long. So the butt joint along this handrail section we have stapled together on the inside of the join, and then we can push and clamp it into position and then clean that up afterwards. Okay, so I haven't filmed for a little bit just because we're trying to get stuff done. So at the moment I've got both stringers made and pretty much sanded up, ready to go for the lower set. The two stringers for the taller set, one of them is being glued up in the mold right now, and we'll finish the other one this week. We're also having to glue up the handrails at the same time, so it takes a little more time. So all we did was use an electric hand plane to clean up the glue on these edges, and then sand, and there's little bits and pieces, little voids and things where some of the plywood moved around. So we have bogged up using like a builder's filler, and then these edges are going to be veneered. I'm waiting for the veneer to come in. So other than that, other than veneering these stringers, these are done, but I do need to create on what is like, what we call it, the plumb cut. So this face here would sit against the floor, and this would be a vertical plumb cut. And I'm going to rebate some of the stock off each side to create a tongue in the middle, and I'll be able to slide down onto that tongue, well, for want of a better word, I'll call it a newel post, but it's essentially just an end post of. We had glued up some large pieces of maple, and I'm just cutting that into the post stock now. Now that the handrail had been cleaned up, we can add a top capping, another 10mm piece of maple, and this just hides all the laminates and provides a bit more heft to the shape of the handrail. On the side of the stringers, each stringer had a couple of butt joints, so we could just route out that little gap that was created and put a little filler piece of birch ply in there. Now I wanted to give some perspective on these posts I just showed you, and I realized I haven't actually explained about the posts. So the newel posts, let's call them newel posts, they're not required for the strength in this particular design. I purposely worked with the engineer to make it so the steel spindles we're going to have are going to be the structural element that combined with the curve. He kind of did all the maths on that, and we worked out a way to secure these spindles in a structural way. That way I don't have to worry about having a really structural connection for the posts, even though the bottom one is going to be quite good. The top one is not going to be as strong as it could be, or should be perhaps, but in this case it doesn't have to be. It's not actually doing a super lot of work. It just has to be connected on in a way that it's not going to fall off. It's mainly there to look good and to provide us somewhere to stop our handrail into. So I've got this large piece here. What's going to happen on the top, so this is our plumb cut, and our top stair is about there somewhere. I'm going to sit this post on the top of the stringer, and I'm about to glue on these extra cheeks onto the side of my post, and they're going to go on like that, one on each side, and then I can just slide this post assembly down onto the stringer where we want it to be, and we'll put some glue and screw this in place, and that's going to provide enough strength for what we're doing. So that's the plan here. That's why the top one is quite different from the bottom one. Part of that, this part of this design solution for the post is because right in here somewhere there's this massive piece of steel which has got to be embedded into the string here, which is going to hold the stairs up. And given that there's an 8mm thick piece of plate in here somewhere, I didn't want to be digging too much out of the stringer with bridle joints or anything else that might kind of compromise even more so the strength of this end of the stringer. And doing it the way I have, we're just going to have lots of surface area glued onto the cheeks of the stringer, and we'll get a couple of screws in where we can, and that is the plan. So lots of things to take into consideration, but we're getting there. Right, so we've got this veneer with a fleece backing. So it's like a, well, it's kind of like material stuff. So it holds the veneer pretty flat and it's easy to work with. So we're going to cut this veneer into strips, and then we can use contact adhesive to glue those strips onto the top and bottoms of the stair stringers. make them look like one piece of wood. Once all the top caps of the handrail are glued up, we could shape the handrail. And I can work out what height the posts need to be trimmed to. With all the top posts glued up, I could trim them on the bandsaw and then shape them with a sander and with a router. So I've got the handrails cut. We're masking taped off where each tread's going to go, and then below that we've scribed a line. That is going to be the thickness of the actual step. So then we've got to add some steel brackets onto here, and one that goes across the front of the steer tread, and that's going to hold the two stringers together and take the weight of the tread. And that's all been worked out by the engineer. So now that this is kind of scribed here, we can get rid of all the masking taped parts and start prepping these to start clear coating. In the meantime, the really big pieces of steel had arrived that need to be embedded into the top of each stringer, so that was my next job. The steel flange will be covered by a 2mm thick piece of birch plywood on top of that. So that's what I'm just being careful to chisel out, is the little pocket for the cover. Because of the two different angles on the inside and outside of the stringer, the steel couldn't be slid in from the top like I had wanted. So we had to take one stringer out and then try and slide it back up once the steel was in place. Obviously this wouldn't be an issue if the mold wasn't there, but we still needed the mold at that stage, so I had to kind of make it work. I measured the length of the stringer with a piece of string and then could kind of guesstimate, calculate the gaps or the spacings of the steel railings, and could transfer those marks onto the handrail at the same time. Then using a pretty basic jig was able to drill the holes plumb, as plumb as I could make them. We used the CNC to cut the theoretical shape of each of the treads, which saved a lot of time. And then we could kind of hand fit each one of those as the stringers are a little bit non-regular. Once that shaping was done, we then glued on the solid maple flooring on top of that. So these are pretty heavy steels, 6mm thick, angle iron. This is all spec'd out by the engineer. Bit of a tight fit here. So these steels have got to go across at the front of every tread. There's a couple of reasons. One, they're obviously supporting the tread and they're also linking the stringers together. They're also, by virtue of the depth of the angle iron, making the gap between each tread to a legal limit, which is going to be 100mm or less. So that's why there's a piece going to be exposed and hanging down at the front. So all those holes I just drilled is to support these steels, and then on the inside of each stringer there's another angle iron which is to support the back edges of each tread. And most of that I think is going to be done on site. I don't think I'll do that in the workshop, just because I don't want to get too ahead of myself. We are finding every time we touch these stringers we damage them in some way. They're so big and clunky and heavy, and everything we tend to do dents it and dings it. You can see there's marks all over it, marks here from getting this in place. So it looks like after we install the stringers and these steels, we're going to have to probably sand and refinish in place. But at least we'll get a couple of clear coats on it as a base coat, and then we should only have to put one extra coat on site. Fingers crossed. Each of the spindles is solid 16mm steel, and every fourth spindle has to be screwed right through the top of the handrail, according to my engineer. So that's what I'm doing here, is just allowing the plug holes for that. Once on site, the first thing we had to do was just hold one of the stringers in place, just to get an idea of exactly where, left to right, the steers needed to sit at the top. Yeah, so that's what we're doing, and then we can work out where to place the steel and get that fixed. Yeah.
We can just chisel that
Almost just
around.
want to router.
Yeah.
Where, how far do you say we've got to drill?
Put the drill up here. Just before you get that peak, about 15 mil. Is that right out?
Yeah, I mean, I don't know if I could get 15 mil. We'll go to, and we'll just hit, we'll try just on that piece. Right, that's great. What? It's just meant to slide on.
What?
That's crazy. I'll just mention as well that there are large hold down brackets at the bottom of each stringer, because I don't think I show it. Unfortunately, all the treads still needed some fine tuning, so that was my job, fitting each one of them again. so it's about this, it's the end of the 4th day. I've allowed a week, 5 days, to install this. It was looking pretty tight time-wise to get everything we needed done. So I've stayed on late on a Thursday night, and I've got a hotel room like just up the road. So I'll be doing as much as I can. I'll work for another half an hour or so, and then I can be here at 6 in the morning or 7 in the morning, and we should be able to smash the rest of it out by the end of Friday. It's just lots of little details to go over, mainly a lot of filling of little screw holes, plugging things, sanding things. I think we'll make it, so let's hope. And that is about it. You might notice there's no handrails around the stairwell. That was not part of my job, but the clients have since asked me to do all that as well, so that will happen at some point. But otherwise, thanks for watching, everyone. I hope it wasn't too disjointed for you to follow, and I'll see you on the next one.